So now we've reviewed how the LTI launch works, and we've taken a look at those core tables, the key, the context, and user. And I want to talk now about how those two things are connected together. And so if you recall, it's this moment where the post data is coming in. We check the signature, we validate all this stuff, and now we have to update all those tables. The part about validating the signature, and then this part right here, provisioning the user, course, and session. That's the important part that we want to do with this big join. And that's where these tables are set up. That's what these tables are set up to solve. And so here are the tables again. We have the key, LTI key is the tenant, users, contexts, and then memberships, and then links and results, and then services are just kind of a lookup table for the LTI1 service URLs, which don't change quite as rapidly as the result URLs, or the result resource links basically in LTI2. And so the key thing is what we want to do, and some LTI implementations just like dump everything in session and then move on. We don't want to do that. We want to basically create sort of a permanent understanding of this user as long as the user, until we delete the user basically. And so we have to do things like figure out what we know in all these tables before, at the moment of launch. We're being presented a bunch of data. Here's this user's primary key in this tenant. Here's a tenant. Here's the user's key or the course key, course title, etc., etc., etc. And so there's a lot of problems to solve in here, right? We might be seeing a user for the first time, a resource link for the first time, a context for the first time, and we might need to insert a bunch of stuff into these tables. Or we might have the user already and the resource link already. Remember, we know what their primary key is within tenant. And so we see new data like maybe we've seen the email for the first time, or maybe we're seeing a new email that's already, we got an old email, and on this launch we see a different email because they updated their email in the LMS, and we want to handle that. The most common case is, we're seeing the 40th launch from this user and we've already got all the data in the tables. So the most common case is the data from the LMS matches of what we've already got in the tables. And it's a more rare case. It's the most common case is we already have the data. The next most common case is we don't have the data and we have to insert it. And the third most common case is we have to do some kind of a small update because we've got a little bit of new information. And it might be like a URL for a result resource that has changed as well. And then once we've got the database all figured out, then we've got to provision the session and then make these global objects like user, context, and link so that all of the PHP code works the way it's supposed to work. So this is what we call the big join. So there's a couple ways we could do this. But because the common case is that we've already got all of the data, this big join really effectively says, I'm going to create this really long join that goes across all of the tables. I want to make exactly one round trip to the database. And so it's a big left join because we don't know if the data exists or not. So we start with the key, the nonce, the context, the link, the user, the membership, the profile, the service, and then the result, including grades. And so there's even things like you've got their profile email, you've got their role, you get their user ID, their display name, their email. In a sense, you get everything you need to know about this launch in a single giant join. But because they're left joins, there could be missing pieces in what comes out of this join. But if there is something, you get it. And a good example of that is like how this nonce works. So we could have a separate nonce table and we could look the nonce up, or we could just like join on the nonce table too. Just left join it. If we in the case of the nonce, if we find the nonce in the left join, that's actually a bad sign. Okay. So, and then there's actually one more database update to insert the nonce into the nonce table. So there's one giant select. And in the common case where our database data matches the launch data, the select is glorious, it matches perfectly, and we do nothing else. Okay? Now, after the big join, So it might be completely empty, right? Other than the key and the secret. The join might be completely empty. It might be all new data, right? Which means we got to insert, 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 right? Or we might compare all of the data we got back in the join to the launch data, and we're like, oh, it matched perfectly, right? This is actually the most common case, that it matches perfectly. And then every once in a while, we'll have slight mismatches between this long join and the launch data, because the join is pretty much includes everything that's in the launch, pretty much. And then we have updated. And so we've got this routine. You can go look at the code here, LTIX adjust data, and it cleverly looks at the difference between the launch data and the data that came from the big long join, and does inserts or updates and does all this stuff, so that when it's done with that, then it matches. The LTI tables are a clone of the launch data, either by adding new stuff or updating, but when it's all said and done, we have absorbed any changes or modifications or new information that we've seen. And there's a few inserts and a few updates, but they're relatively rare compared to like just this perfect match. And so that's why it's really cool. So it takes exactly one SQL query with all highly indexed keys and all integer keys on the way across. So it's all really relatively cheap, and you don't have to ever do a second select statement ever. You do have to do an insert statement to the nonce table, which stays relatively small because the nonce table has a probabilistic thing that throws them away after 30 minutes and stuff like that. But so there's really sort of like one query that matters, and then the little cheap nonce query, the insert. So, and once we've got the table all fully updated that matches the launch data, then we construct a session based on all that essential information, all the information effectively that's in this. That's a combination of derived information from the tables as well as information from the launch. So it's really a combination of the launch and the table. So we then provision the session, redirect to the beginning, and then from that point forward, all further request response cycles don't touch this big join again. The big join only happens at the moment of launch. You're just clicking, then all the data is already in session about what the display name is and all those other things. And things like the $user variable are populated out of the session on all successive request response cycles for that tool, as long as we don't lose the session, user context, etc. So there are 0 database transactions in the framework after the launch. When the launch happens, there's 1 select and 1 insert. So I'm hopeful that this is efficient, so that when you're building tools, the framework itself does not become the performance limiting factor. Frameworks shouldn't be performance limiting factors.